Let starts SIIT-Jee mathematical series. For today, we will start the new topic sequence series. Very important for Jeemain, advanced, and also KVY. So let's start sequence series. So what is sequence? Sequence is nothing but a function. What kind of function? Must be the domain of the function will be natural number set. So here a sequence on a set, particularly on a set, means maybe real sequence or complex sequence depending on the set. So here X is in an arbitrary set and it is a mapping or any function, and that is represented in such a way that f from n to x, and that is defined by fn equal to f suffix n. So what is it? That means for 1, 2, 3, 4 dot 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 from the domain set n, namely here n is sequence, a domain of that sequence, and the corresponding sets, let us suppose that set is x, represented in such a way that looks like this side. For 1, it maps element, let us suppose that element in the sequence pattern will be f1, f suffix 1, or whatever if you wants to represent in that notation f1, also you can represent it. Also for 2, f2. That means for any element of the domain, here domain is n, there must be a one element in the codomain x, one element which maps 3 to f3, generally n map to fn, and must be for all n belongs to capital N, and that is trivial because of a function. For every element of the domain there is an image in the codomain. Generally a function is represented by f of n, and here n rising in natural number set starting from 1 or whatever, started from n0. N0 is any small element of the domain set. Here domain in particular is natural number set, and fn, n belongs to capital N. Simply sometimes not, more or less maximum time we use in this notation, simple fn. In particular, if a sequence is in kind of when x, that means the codomain set here is r means set of a real number, then the corresponding sequence is said to be real sequence. So the real sequence is nothing but one kind of sequence where the codomain is real number set. Now let's second point. Here second point means similar as real sequence. So what is second point? States that here x equal to c. C means set of all complex number. If x equal to c, then the corresponding sequence is said to be complex sequence. So complex sequence is nothing but f from n to c. Now let's approach a new topic, series. So what is series? So for beginning of a series, we need a real sequence or complex sequence, but in our syllabus there is more generally a complex sequence. So let us suppose we have started with a real sequence. Let a1, a2 dot dot an and are the element of any real sequence. Then the expression like a1 plus a2 plus a3 plus dot dot dot, that means sum of all element in the sequence an. I repeat, let a1, a2, a3 dot 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 an be a real sequence. What? A real sequence. Then the corresponding expression like a1 plus a2 plus a3 plus dot dot dot, it's called a series. Corresponding, here please note that corresponding is very vital, because of for every real sequence there is a series. So these series are coming from that sequence. That sequence means that sequence, and this series sequence is obviously written here, an equals to a1, a2 and so on. More generally, a series is denoted by an. So be noted here, and that is a series notation, and this is a sequence notation. So I am writing here n equal to n0 to infinity. So what is n0? n0 is nothing but a smallest value of the given domain. Here, maybe, in particular case, maybe the domain set subset of natural number set. For that case, that n0 may not be equal to 1 or more than 1. Normally n0 equal to 1, but our syllabus n0 equal to 1. So now let's start another topic, progression. So what is progression? Progression is nothing but one kind of sequence having some pattern. So here stated like that, a sequence following certain pattern is called progression. So sequence, when we modified it in such a way that having a pattern is called progression. So basically there are three types of progression in our syllabus. The first is AP, full form of AP is nothing but arithmetic progression. The second one is GP, geometric progression. And third one is HP, harmonic progression. Now categorize these three progression. First one is arithmetic progression, second one is geometric progression, and third one is harmonic progression, and all are written in a short form HP, AP, GP and HP respectively. So first, what is AP? Obviously we already learned in the previous section that AP is nothing but one kind of progression. What kind of progression? Having some property like the difference of any two successive number in the sequence an having the same difference, and that difference is said to be common difference. CD all times, sometimes it is denoted by CD or common difference written here. That is D common difference equal to A2 minus A1, A3 minus A2, A4 minus A3 and so on. So if we generalized the nth term of the sequence, what it would be look like, the nth term of the sequence is looks like that n equal to a plus n minus 1 into d. So what is a, what is n minus 1 and d? So simplify the three unknown terms. First one is a. What is a here? Here first term is a. First term means a1, a2, a3 and so on. This a1 is namely written here a, and that a here. So a. And if we want to find the nth term of the sequence, then n will be a plus n minus 1 into d, and that d is nothing but common difference of that sequence. So for any particular sequence, the common difference is unique. So first one is the nth term of a sequence. The next one is, if we want to the sum of the sequence, that means if we want to find the series corresponding to the sequence an, then what should we do? The sum of the series ai, I from 1 to n, that means if you want to find the value a1 plus a2 plus dot 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 up to an, that means we have a sequence an and we want to find the sum of the sequence up to n terms, then that value it will be represented in the formula form in such way that n by 2 plus first term plus last term. So first term we already learned that first term is here a, written in the notation a, and the last term will be denoted by l. In particular here l is an, and we already learned that an is nothing but a plus n minus 1 into d. Now put this value in this form, n by 2 first term plus, in place of l replace a plus n minus 1 into d, and you easily get that value is looks like this form, n by 2 plus n by 2 into 2a plus n minus 1 into d. Now next go to the second point, progression, and the next one is GP. So what is GP? We already learned that GP is nothing but geometric progression. So geometric progression is kind of progression having the property. What kind of property? That the fraction value or the ratio value corresponding to the sequence an, successively ratio will be the same, and that ratio is said to be common ratio. Here common ratio is denoted by R because R stands for ratio and here D stands for common difference. So here Tn is nothing but a times of R to the power n minus 1. So what is a? Similar as AP, A is nothing but the first term of the sequence and R is the common ratio corresponding to the sequence. R is nothing but A2 by A1, A3 by A2, A4 by A3 and so on. This value is generally denoted by R. And here if you want to find the value of the nth term of the sequence, then that value will be represented in such a way that Tn equal to A into R times R to the power n minus 1, where A is first term, basically A1 is first term represented in a sequence. Because of sequence looks like A1, A2 and so on. The first one is denoted by A1, here is also A1. Now if you want to find the sequence, if you want to find the corresponding series of the sequence, then sum of the series will be looks like A times of R to the power n minus 1 by R minus 1 and must be that R not equal to 0, not equal to 1, because of if R equal to 1, then the numerator denominator must be vanishes and that goes to infinity, and we are concerning on the real number system, so we neglect this value just because of we have a real number system. We all know that real number system is starting from minus infinity to infinity, so we don't have the infinity. And next go to the next point, and the next is HP. So what is HP? HP stands for harmonic progression. So what is harmonic progression? So harmonic progression comes from arithmetic progression, and that is a special type of progression, and that progression looks like that if a sequence an be kind of having the property 1 by A2 minus 1 by A1, that means take the value corresponding to the sequence and just reciprocal that element and subtracting respectively that reciprocal value, you will get a particular constant, and that constant you represent any constant, namely suppose here x, and that is A2 by 1 by A2 minus 1 by A1 equal to 1 by A3 minus 1 by A2 and so on. And this value, if this is constant, then that sequence an is said to be are in a harmonic progression. That means 1 by an be in what? 1 by an be in AP. AP means arithmetic progression. So now you already you will already see that here I am writing here A, G and H. So what is A, what is G, what is H? For we formalized these terms, these three terms A, G and H for any two elements. So let us suppose two elements are in AP, and generally for any two element AP means having some common difference corresponding to the element of the sequence. So let us suppose that sequence looks like A1, A2, AN and so on. So for two element A1 and A2, let us suppose any arbitrary element A1 and A2, and that corresponding A1 and A2 we have a arithmetic mean. That means here A stands for AM or arithmetic mean AM. That series is known as AP, GP, HP. AP corresponding AM is represented A plus B by 2. But here A1 plus A2 by 2. Like here also, for any two element in the sequence A1, A2 and so on, the G, that means geometric mean, it looks like the square root of A1, A2. For if you want to find for two elements, if you want to find for nth element, so what it will looks like A1, A2 an power of 1 by n, and here also A1 plus A2 plus an by n. And for harmonic progression also, H is nothing but harmonic mean of two element here A1, A2 and so on. A1, A2 for A1 and A2, 2 by 1 by A1 plus 1 by A2. If you generalize this form for n particles or n elements, A1, A2 and so on, so it looks like in the form as A is equals to n by 1 by A1 plus 1 by A2 plus 1 by A3 and so on up to 1 by An. And we completed here the basic part of sequence, and that is very important for Jeemain, JEE Advanced and also KVPI and other competitive exam.